Okay, in the second part of this homework, for the given function f and g and the exercise 29 and 44, state the domain for each composite function. In 29, 31, 33, 35, 37, 39, 41, and 43. Okay? Okay, 39. Again, state domain. Domain of G. Es obvio que es all real number. New expression. New expression f composition G is like a radical 2x plus 3. Then, for finding the domain of this, you copy the expression inside, must be non-negative. Now, so for x is 2x greater than or equal minus 3, bar by 2 both sides, x is greater than or equal minus 3 half. Okay, now the domain for the new expression is all real number such that satisfy this condition must be greater than or equal negative 3 half. And the domain of the f composition G is the intersection both sides. This is an all real number, of course, this only one. Let's see backward. Let's see G composition F. Okay, now let me work in here. Let me erase the here. Eraser. Okay, now it's different order. Is domain of F. Domain of F is equal only positive number. Okay, the expression inside the radical must be non-negative, so 0 or positive. New expression is G composition F, is F go inside G, this is 2 radical x plus 3. It's obvious that this is half restriction because again we have a square root, but it's the same. The domain of the new expression is again x greater than or equal to 0. Now the domain of the composition G composition F is this and this, que is exactly x greater than or equal to 0. They correspond with the option 2. It's the same routine. Okay, let me erase this part. Okay, now F composition F. The domain of F is domain of this is positive number, that's 0, no negative number. Domain of F. New expression when you form the composition F composition F is radical x, so radical. This is radical box, and inside the box you copy again F. This is 4 root of x. And domain of this again is domain of new expression is again positive number, remember, because it's even index, no allow negative. Now domain then of F composition F is exactly the same, x such that x greater than 0 corresponding with the option 3. Okay, let me try to do in this part G of G. G of G. Okay. Okay, domain of G es obvio que es all real number, linear function. New expression when you form a G composition G is 2x plus 3 plus 3 is 4x plus 6 plus 3 is 4x plus 9, and domain of the new expression again is all real number, therefore the domain of the composition G of G is also all real number according to the condition 4. Okay, 41. It's the same, but I changed the function, new function. Let's do it the first. Domain of G. Domain of G is equal. Well, you take the expression inside. Minus 1 must be no negative. X must be then 1. Domain of G is x such that x must be greater than or equal 1. Now new expression. New expression, okay, you form it by F composition G. Is G go inside F, so I put the box a squared plus 1, and inside you put the square root x minus 1. Okay, square root and square cancel out each other, it's x minus 1 plus 1, cancel out x plus 1x, is just x. Then the domain of new expression is a real number, and the domain of composition F composition G is the first restriction, is x such that x greater than or equal 1 for the condition 1. For the condition 2, domain of the function G composite F. Domain of F first. Domain of F is a polynomial function, it's a real number. A new expression. New expression G composition F as you put F inside G. Entonces like a square root, instead of x is x squared plus 1, entonces x squared plus 1 minus 1. Cancel out positive 1 and negative 1, and the square root x to the second power is just x. Now the domain of the new expression again is a real number. Then the domain of G composition F is all real number for the option 2. Okay, let's continue here. Eraser. No erase the function. Erase only this manipulation. The function stays the same. Okay, 1 here, minus. Now is domain of F composition F. For finding that, you find the domain of F. Okay, it's all real number. A new expression is a composition F and itself. This is like a box, square, plus 1, and inside we have x squared plus 1. And you apply quickfoil, x to the 4 plus 2x to the second plus 1 plus 1. It's x to the 4 power plus 2x to the second plus 2. It's a polynomial. This is a polynomial. Domain of the new expression is all real number. Now conclusion, the domain of F composition F is also a real number. This is the option 3. Okay, now let's go to the last option, option 4. Option 4 is domain for the function composite g, composite g. And g is this weird function. So now, domain of g, I compute before, remember, is all real number such that x must be greater than or equal to 1. And now the new expression where you combine composite g and itself is g composite g is square root, and inside here we have a box minus 1, and you have a square root x minus 1 here. And this, the function is, let me see, is a square root and a square root x minus 1 minus 1. Oh yes, so we have restriction here because we have double square root. So let's see what happens. Now let's see here one okay, so we have one inner radical. So the restriction for this radical is x minus 1 greater than or equal to 0, x greater than or equal to 1. And this is exactly the same with that. Okay, no problem. The second, let's see, is this expression, okay, is inside the outer radical, minus 1, must be greater than or equal to 0. Okay, let me try to manipulate this inequality. This is radical x minus 1 greater than or equal to 1. You square both sides. Is x minus 1 greater than or equal to 1. Then is x greater than or equal 1 plus 1 is 2. Okay, now the domain of the new expression is equal x such that x greater than or equal 1 and x greater than or equal 2. Okay, actually, look, to see this idea, this is 1 here, this is 2 here, greater than or equal 1 is like that, greater than or equal 2 is like that, and the intersection is obvious, okay, it's this part only, and include 2. Then, this is equivalent to say x greater than or equal to only. Okay, finally, one more time, domain of the G composite G is the intersection between the domain of G, okay, is this, remember this idea, domain of this, and domain of the new expression gets this. And one more time, when you are doing the intersection, we can find exactly the same answer, and the answer finally is x greater than or equal to for the combination 4.